I already did the A part, B part, C part, D part in my previous videos. If you want to know how did I do it, you can go ahead and check that. In the E part, we have ID1 to be 0 milliampere, ID2 given 0.16 milliampere, and the question is asking to find out the input differential voltage and also Vs, Vd1, Vd2, and also Vd2 minus Vd1. Now let's see how to do this. Create a new page to do this. Here we are doing the E part. So you can see one of the part is cut off, like this is the circuit we are looking at, and here ID1 is 0. It means the current is only flowing through this, and at that time what is the input differential voltage? And if the currents are, if the current is equal, it becomes easy because vG2 is 0. If the current is equal, vG1 also becomes 0. So we can say since vG1 is 0, VID is going to be 0 as well. But for this one, this is not the case because we have different current. We have ID1 0 milliampere, ID2 0.16 milliampere. So we had to do something else. And if you watch my previous part, I did the D part. D part also similar situation. We had different current, but for that one we used this equation. ID1 is equal to I divided by 2 plus I over V over tri plus VID over 2. That is, we use this one if we have two different currents available. But if one of them is cut off, then we cannot use this one as well. This is when both of them has a current flow. But if one of them is cut off, then we have to use this one. VID is equal to negative square root of 2 times V over tri. Okay. There's another similar one we had in the part C as well, where this circuit was cut off and this one had a current flow. So for that one also we had to use this. If one of them is cut off, we had to use this. So here for this one we don't have the current flow here, we have current flow here. So we had to use exact same thing. And if I substitute VOV I did in the part A of the question. That is 0.2. I found that one to be 0.2, so I substitute that one here. Negative square root of 2 times 0.2, and if you calculate this, you're going to end up getting negative 0.283 voltage, and that's our input differential voltage. The next thing is we had to find out the Vs. Now to find out the Vs, in the first part I derived from the current equation. And this is what I derived. You know, the current equation for the drain current is given by half Kn prime W over L VOV square, and VOV is nothing but VGS minus V threshold. VGS is nothing but VG minus VS. So you have to rearrange all this and get the equation in terms of VS, and if you do that, you will get this equation. Okay, so VS is equal to this equation, that is VG minus square root of 2 times ID1, but in this case we use ID2 because only ID2 has the current, only the second circuit has the current. So 2 times ID2 divided by Kn prime W over L. Oh, my bad. We still use the ID1, but yeah, we always use the ID1. But if it's 0, we substitute 0. Okay, ID1, and what else we have? Okay, let's look at the equation. So ID1 divided by Kn prime W over L. Kn prime W over L, and then minus Vt. Let me double check. Yes. So since the current is 0, everything become easier. This equation will end up being just Vg minus Vt because this whole thing is going to be 0. So we can just write Vg minus Vt. And Vg is nothing but the input differential voltage because it's given in the question. Whatever the gate voltage we have is equivalent to the input differential voltage, and the input differential voltage we found out to be this negative 0.283, and that's going to be the gate voltage. So substitute that one here, 283 voltage, and minus V threshold is we are looking at the parameter in the 9.1 question. So the parameter for V threshold provided right here is 0.4 voltage. Substitute that one here. So this one becomes negative 0.683 voltage. Okay, that is our Vs. Now we have to find out VD1, VD2, and also VD2 minus VD1. So let's go ahead and find them. Now VD1, if you look at the circuit, the equation is already there, VDD minus I divided by 2 times RD. If you don't have the equation, you can always derive by looking at the current here. The current flowing through this should be equal to this voltage minus this voltage divided by the resistor in between. In this case, this voltage is VDD and this is VD1 divided by the resistance in between is RD. That should be equal to whatever the current flowing through this. So for the first one, the current flow through is ID1. For the second one, the current flow through is ID2. Even though for the part we are doing, there's no current flow, so we are just substitute 0 for it and see what we are getting. So if you rearrange in terms of VD1, this is the equation you get. VD1 is equal to VDD minus I divided by 2 times RD. This I divided by 2 is for the diagram given, but in our case, this is the current flowing. Like if the ID1 is this, that is equivalent to I divided by 2. So instead of I divided by 2, we can say ID1 as well. Okay, so let's go and write the equation. VD1 is equal to VDD minus, instead of I divided by 2, so I put ID1 times RD. And VDD, we are looking at the parameter in the 9.1 question. VDD is 1 voltage right there. So plug that one in, and then the current is 0, so anything else doesn't matter. So this is just 1. And then VD2, exact same equation, VDD, but in this time we are going to have ID2 for the current and RD. ID2 has a value, VDD is 1 voltage, ID2 has a value that is given to us to be 0.16 milliampere. So we have to substitute that one here, milli, and the RD we have to look at in the 9.1 question for the parameter that is given 5 kilo ohm resistance. So substitute that one for this. So 5 times 0.16, that one gives us 0.80. So 1 minus 0.80, that is 0.2 voltage. So we have VD1 and VD2. Now lastly we have to find out VD2 minus VD1, that is output differential voltage. VA output differential voltage is equivalent to VD2 minus VD1, and we have both of them available. VD2 is 0.2 and VD1 is 1 voltage, so we will end up getting negative 0.8 voltage, and that's our output differential voltage. Okay, so we found out all the values expected. We have VD1, VD2, VD2 minus VD1, and then we solve for the input differential voltage, that's VID, and also we found out Vs right here. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys.